Hello, and welcome to another episode here on Total Space. I'm Rich LB, and with me today I have Miko and Jack. And also, returning to us, we have Tim Alatorre, COO and founder of Orbital Assembly. Hi Tim, how are you doing today?
It's good to be back here again, and congratulations on 2 years of your show. That's really exciting.
Thank you very much for that.
Yeah, great to see you again. We met about a year ago, so would you go over what new has happened in the past year?
A lot. I mean, that's the short answer. You know, one of the challenging things, we were talking about this just right before the call, is we have these grand visions and things that we are going to be doing with Orbital Assembly Corporation, but there's a lot of foundation building and steps that need to happen before we get to orbit, obviously, and have big space stations. And so this last year has been really working on those foundational pieces of the early steps. And for a lot of our supporters and investors, it's a little frustrating because there's not a lot of visible things, tangible hardware that you can see yet. But it's laying all the groundwork and making sure that once we are ready to move, things are going to be going smoothly. So this last year, we've done a lot of work on the financial side of getting to space, which not being funded by a government entity, that's really one of the more challenging pieces of the puzzle of getting all the financial side put together. And concurrent with that, we've also been working on our design quite a bit. So last time we spoke, our roadmap actually took us, we were going to be doing the Gravity Ring project and then moving on to Pioneer. And as we started working with our vendor partners, we have fantastic suppliers for our key components and systems that have flight heritage. They've been operating in the space environment for decades. And as we started working with them on some of the more detailed design, we realized we could actually skip quite a few intermediate steps that we thought we were going to have to do. And so now we're focused right now on going straight to Pioneer Station and having the first module be our first mission. So that's a huge shift from the last time we talked. The Star platform that we demonstrated in California last year is fantastic, and we still have some interest in that from a couple of different customers, but we don't need to go to that as a stepping stone to Pioneer. So that was a big shift. And then, with our design being more finalized, we put together an operating manual for Pioneer Station for people wanting to actually use the station, and we've been shopping it out to customers. So we have a number of people that we've been working with, both customers who are looking to lease space and operate on Pioneer Station, the first Pioneer Station. And then we're also actively shopping and working with customers who are interested in buying their own Pioneer Station, which is really exciting. And that's a new development from last year. We've been able to get the price and the timeframes low enough to where now it becomes economically feasible for, I wouldn't say individuals, but well-funded organizations and governments to just purchase their own station outright. So we're looking at right now a number of Pioneer stations most likely being constructed concurrently over the next couple of years. And we'll see which one materializes first. Also with that, because we've been developing these technologies and other components, we're also in discussions right now with a couple of companies who are looking to just purchase modules and some of our hardware for other applications and other commercial space stations. So a lot has been going on in the background. We're really hopeful that in the next couple of months, we're going to be able to start some construction of full-size assets and mock-ups and flight hardware. And that's where we're at right now.
Well, that's fantastic. Nice little update there. It looks like you've taken out an entire step on your way to where you need to go. So last we spoke, as you mentioned in your answer there, we spoke about how Gravity Ring would be constructed using, if I remember right, is it P-Star? So that would have been constructed, and then there would have been scientific payloads on there that you could then spin up and spin down, subject them to various levels of gravity. So with you skipping over to Pioneer Station immediately now, are there still plans to have payload spaces for scientific payloads even on Pioneer Station?
So one of the things that our market research started to discover kind of towards the end of last year, end of 2021, there was a lot of demand for microgravity capabilities. There's a lot of companies who've been doing experiments and doing research on the International Space Station, and they have these amazing proof of concepts, but they want to take them to market, and you can't do that on ISS. There's just not the space, there's not the ecosystem for commercial trade. And right now, actually, on ISS, for companies wishing to do work there, there's a massive backlog of years. And so for a company wanting to do something, it's just a non-starter on ISS. And so as we started, shopping around the capabilities of the P-Star gravity ring truss, there was some tepid interest in near-term opportunities. A lot of interest for doing microgravity or artificial gravity research, but companies just aren't ready, and scientific institutions aren't ready. They're like, oh man, that's really short. If we had a couple more years, we could probably be ready. And so that coupled with the technological advances that we made where we didn't need to do that step, that actually opened up Pioneer, the first phase, which is going to be microgravity capable, to a lot more customers who are ready right now. So the first phase of Pioneer Station is going to have research and manufacturing and other activities that are microgravity focused. And then phase 2 of the Pioneer Station construction will add in the artificial gravity capabilities. And so that timeline actually lines up better with where our customers are at in their development. So, microgravity isn't as exciting necessarily. We're all about artificial gravity and getting people up into space for long term. But from a market standpoint, and again, funding the steps needed to get to the larger stations like Voyager, the first phase Pioneer Station is a really good stepping stone. And the technology needed for the first phase Pioneer Station is already available. There's no technology development. Everything is very high TRL, technology readiness level on the hardware side. So that lets us get an operational station with less risk, less cost. And then the artificial gravity capabilities, which there is some technology development there. The mechanism that allows everything to spin and rotate hasn't been tested on orbit. So we can phase that in, reducing risk, basically.
Yeah, that's very important to test out on orbit. I'm quite interested. What do you think? Who will be buying the first station? Would it be a country, meaning a space agency, or some actual corporation?
So I have a pretty good idea about that. We are currently in discussions with a couple of potential buyers. Unfortunately, I can't talk about that yet, but hopefully in the next few months, we'll be able to make an announcement. The cost for the first phase Pioneer Station is really low compared to even other satellites that have been put on orbit, and very low compared to terrestrial construction projects. But it's still a sizable enough dollar amount that it's probably not going to be an individual or a company. The first one is most likely to be a larger organization, and that's about all I can say. I mean, honestly, though, if an individual wanted to purchase their own space yacht and have us build them a space station, it's the first phase Pioneer Station costs less than many luxury yachts that billionaires have, on the world's oceans. So it's not out of the realm of possibility either. I just don't necessarily see that happening as the first one.
Yeah, I can totally see quite a few space agencies having their own stations in future.
Well, what's interesting? We've been making efforts to kind of get out into the world a bit more and have more conversations with international markets. And there's this perception, really even here in the United States, that space is accessible through NASA or European Space Agency. You have to go through one of these agencies to get to space. And what that's resulted in is a lot of countries just not participating, or participating in a very small way. And so the message we've been trying to get out to really everybody is space is open for business. You don't have to go through the traditional gatekeepers. If you want to work in aerospace, you don't have to get a job with NASA. There's dozens and dozens of companies that are hiring. Likewise, if you want to have a station on orbit or do work on a space station on orbit, you don't have to go through NASA or ESA. There's other options now. And so, the advent of, multiple space stations on orbit, we've already seen that the Chinese have their space station on orbit. I think, in the next several years, we're going to be seeing many more space stations in orbit. And yeah, it's a very exciting time, making space accessible to more people.
And speaking of making space accessible, actually, you recently announced a partnership with Cislunar Industries. Is there anything you can expand on that with?
Yeah, we're really excited. We've actually been working with Cislunar Industries for some time now. We were finally ready to make that joint announcement of our collaboration. But Cislunar Industries, for those who don't know, is a company that is looking to basically recycle metal on orbit. And so there's a number of different ways they could get that material. but then essentially that material gets melted back down and converted into material that could then be reused, either in a 3D printing scenario or cast into something or deorbited to the moon or some other location. And so Cislunar Industries has done some successful demonstrations. Their hardware's, TRL 5 or something like that, 6 in that range. And so what's exciting about the partnership between Cislunar Industries and Orbital Assembly is we offer a hybrid gravity environment. So we offer microgravity and artificial gravity. And when you're doing metallurgy processes, there's interesting opportunities in a microgravity environment that you don't get on Earth. So there's certain metals that, because of gravity, they're going to not create a usable alloy here in a 1G environment. But in microgravity, you can create interesting alloys, have metals that wouldn't normally bond and join together. So you can get different properties, metallurgy properties, right? But then if you're looking to 3D print metal, you really need some gravity level to make that process work. And so being able to do some processes in microgravity and then other processes in artificial gravity allows Cislunar Industries to do a lot of things that they wouldn't necessarily be able to do either here on Earth or in a traditional micro-G space station. And then, just looking forward, also having a company working on our station who is developing cutting-edge metalworking processes opens up a lot of doors for us on the construction side as well, right? There's a lot of opportunities. And I'm not at liberty to talk about those yet, but we've got lots of different ideas and things that are in the works. Not necessarily for like the phase 1 Pioneer station, but as we start looking at future phases and pushing the technology envelope a little bit, there's some exciting things.
And I'm sure as an architect, you can genuinely appreciate these new metallurgical properties as well that this potential has.
Absolutely. And I'd be remiss not to mention Relativity Space. They are doing really exciting things with 3D printing of metals. Cislunar Industries isn't so much focused on the 3D printing part. They're more focused on the materials, the stock that can then be used by the 3D printing processes. Relativity Space on the 3D printing piece, they're on the cutting edge of what's able to be done with 3D printing. I can't talk about any kind of partnerships or anything with Relativity Space yet, but we've been in conversations with them, and our CTO's got a tour of their facility, and they're doing some really cool stuff. So I look forward to future collaborations with them as well.
Awesome. That's great stuff to hear. When companies like that come and work together, that's when big things happen.
Well, that really is the key, is working together. Orbital Assembly is not doing this alone. Over the last year, we actually have acquired over 60 signed agreements with different partners and customers. We're trying to kickstart commercial ecosystem in LEO. And so we as one company can't do that. So that's why we have 60 plus companies we're working with. We're all working on this problem together. And everybody has their little focus areas and their strengths, and everyone has a need that someone else is filling, right? And so we're going back together. It's not one person or one company that's going to make this happen.
And that's what makes it an economy, right? One company has something the other company needs, and then they trade, and then it's how it works. That's how you kickstart the economy.
Well, absolutely. And that's some of that behind the scenes foundation work that people probably don't appreciate. They're like, what's Orbital Assembly doing? Well, it's building all of these relationships, right? It's not really a chicken and egg scenario. It's like this big loop, and trying to close that loop and get back to where all the pieces are fitting together. That's the big puzzle piece.
And speaking about the economy there for a second, with these Pioneer stations, are you at liberty to tell us how you're managing to keep your costs so low currently? Is it because of any prior steps and prior learning that you've done up to thus far, or is there more to the story?
Yeah, there's definitely a combination of factors. I would say our team is probably one of the key pieces to that. Our core team comes from a wide variety of backgrounds. So we're not looking at the problem from a traditional NASA cost plus process. We're looking at it from a bunch of different commercial and technological angles. And then we have people on our team who've flown a lot of missions to space. So Dr. Tom Spilker, our CTO, he's flown spacecraft to pretty much every planet except for Mars. And he worked on Voyager, which is now outside the solar system. So, he's been there, done that. He understands space architecture and space systems. And we have other team members who've launched countless missions to space, dozens and dozens. So we have a good solid understanding of what's needed to operate in the space environment and how to make things commercially viable. And then we put a lot of effort into finding the original source vendors for different systems. So if you were to go, for example, if you go to NASA and you said, hey, NASA, can you build me XYZ. They're not necessarily building that. NASA does do some fabrication, but most of what they do is outsourcing to other companies. And the contracts that NASA usually acquires are with bigger companies, the Boeings and the Aerojet Rocketdynes and Northrop Grummans, but they don't build their components either. They're going to other companies who are then going to other companies who are going to other companies, right? So we've put a lot of work into finding the actual people making the parts, right? The actual people welding and screwing and casting and machining, and going to them and making our relationships with them. So we're cutting out a ton of middlemen, which equates to, cost markups and scheduling delays, et cetera, et cetera. So I think, those three pieces, solid architecture, understanding we're designing for a business environment, not a cost plus government program, and then finding good vendors and suppliers is really, I think, our secret sauce there.
That's awesome. How about the timelines for some hardware? When are you actually going to think about launching some space station modules to space?
Well, we're thinking about it now. I mean, we've been thinking about it for some time. The time frames that we are shooting for is 24 to 34 months from the time that we have the funds available to start. So right now, we're looking at 2025 to have the first module up. Possibly it might slip to 2026. We're currently in fundraising mode. I mean, we have been for quite some time. And that's through two mechanisms, right? One mechanism, like I was saying earlier, is through customers, lease agreements, just selling stations outright. And the other side is the equity financing side. So we have been in talks with investors, the large institutional investors. There's a lot of due diligence. There's a lot of checks and audits and reviews. And that process is painfully slow. But, that is ongoing. We have a number of interested people. And then, so that kind of sets our timeframes. The one kind of big factor in our timeframe is when we can put our launch deposits down and reserve that launch. So we have some launch windows that we've been in talks with different launch providers. And so we're shooting for some target dates, but until we can actually put the deposit down, then those dates are, they're tentative, right?
Yeah, that timeline seems quite ambitious, and it could happen even before than the next human lands on the moon.
I hope so. There's a lot of companies that are working on private commercial space stations, as you know, and it seems like more keep getting announced every day. The ecosystem is growing. There's well understood demand for getting people into space and having platforms for them to do things on. We would love to be the first for the Pioneer phase 1 of the commercial stations. If we miss that target, I'm pretty sure we're going to be the first for artificial gravity. That's what we're really focused on.
So, Tim, you've got your Pioneer station, you've got it to low Earth orbit, you've got your customers, they're coming aboard, but now they're getting a little hungry. So tell us a little about Micromeet.
Yeah, Micromeet. Yeah, we just announced our partnership with them. So they are a fantastic company. I was actually just at their headquarters and met their whole science team this last week. And just a real smart group of people. Like, I understand engineering and kind of the physical sciences. I was in a room with 5 of, some of the most brilliant biological science people with PhDs. And I felt really dumb, for the couple hours I was there. But what Micromeet is doing is they are developing innovative hardware and processes for cultivated meats. Basically, what they're doing is they're taking animal proteins and replicating them through biological processes to create materials that can be consumed by humans or other living organisms. So if you wanted a chicken, you want to eat chicken, or you want to eat beef, or you wanted to eat pork or fish, or even more exotic mammals, if you wanted to eat elephant, they can take proteins from those animals and then replicate and cultivate them into a product that's edible. So there's a lot of really interesting applications with their technology. Their business right now is supplying other meat cultivation companies with hardware, but we're working with them now on developing a bioreactor that can be used in space. And so what that means is you can have fresh meat on a regular basis without having to have a bunch of livestock living on orbit, which, there's a lot of complications with that. And also, the meat is of a higher quality because when you're growing things the natural way, well, I mean, it is natural. It's just not attached to an animal, right? But when you're growing things like on a feedlot or something like that, there's a lot of bacteria and other pathogens that are introduced. But when you're cultivating that meat in a controlled environment, a lab environment, there are no pathogens, and so what that means is the meat lasts longer, it's fresher, you're not going to get sick from it. It's really a healthier alternative. You can dial in exactly what the fat content that you want in that meat. And so, that's an exciting prospect to have more food choices on orbit. The other thing we're working with them on is taking some of our space age technology, some of the systems we were developing for keeping people alive on orbit, and integrating those into their bioreactor so that they can have better efficiency and higher quality for their terrestrial applications. And so when you look at cultivated meats and high efficiency plant growth and taking space age hardware for terrestrial applications, there's wide-reaching effects for really tackling some of the food scarcity issues that are happening around the globe. Even in the United States, we have what are called food deserts, where you have large swaths of the population that don't have access to fresh foods, fresh vegetables, fresh meat. So if you can start to have these smaller reactors and smaller grow facilities that can produce food for an entire city in a very small package, we're starting to transform what it means to have people have access to fresh food and vegetables. So it's exciting. We experience so many benefits from space, and it's fun to be able to participate in something that potentially could revolutionize the way we live here on Earth and have better food to eat on orbit too at the same time. So,
Yeah. Yeah, I would definitely go taste some micro meat.
So when I was there, the material we were looking at is meat, right? I mean, it's really, really cool. And you start to wonder, what would happen to us as a species if we didn't have to kill to eat, right? Like we know that feedlots have significant impact on greenhouse gas emissions, and there's a lot of environmental impacts. And there's so many people in the world who don't have access to meat. So increasing the number of feedlots would only compound that problem. So, looking at these alternative solutions is exciting.
How about the announcement about Metaverse program, Dream Big World?
Yeah, so Dream Big World, another one of our exciting partners. So Juan de la Scurien, he is an artist. He's from Mexico originally. He toggles between the United States and Dubai, where he lives. But he has a global lifestyle brand called Dream Big World, and they have a number of products and licensed artwork, everything from tissue boxes has his art on it to big brands and resorts. So he's working on opening a couple of physical retail stores, as well as some other exciting things I'm not sure if I'm allowed to say, so I'll let him say that. But just what he's publicly talked about is some retail stores in Cancun and Dubai and Miami. And what we're working with him on is creating a collaboration where people can go into his physical stores and have a virtual reality experience with Pioneer Station. So he's looking to open a retail store on Pioneer Station when it's operational, and then people can come in physically to the store and interact with the space station in some way, right? In the very near term, we're working with them on creating a metaverse experience where people can virtually experience Pioneer Station from their computer desktop. So that's moving along very well. We just had another meeting this last week, kind of working through some of the details. This following week, we're supposed to dial it in and decide exactly what we're doing. So that's really exciting. People want to know what Pioneer is going to look like. Well, we're going to give them an opportunity to actually, navigate it in 3D on their desktop. And then there's some other components to it. There'll be some virtual experiences you can purchase and some NFTs that will be for sale. There's a whole kind of world that he's creating. I think my understanding right now, and I'm saying my understanding because it's not done yet, it's still in the process, but you would log into the Dream Big World metaverse, and then you'll be able to launch, be able to get on a virtual rocket and fly up to the space station, and then you can spend some time around the space station.
Yeah, being able to experience that in the metaverse in VR is going to be really awesome. I've recently gotten to try I believe it was the Quest 2, perhaps? It's our producer's VR headset, and he got me to try it when I was round at his not long ago, and it really is quite fantastic. So being able to be on, Pioneer Station, being able to walk around and see everything, see out the windows, yeah, that's going to be a fantastic experience.
Yeah, we're going to build on it. So at launch, I think we're just going to have phase 1 of the Pioneer Station, and then we'll have some events where, virtually we'll add on to the station. You'll get to see the station grow. So it'll be something that iterates over time, and we'll see where it goes. We'll see what the interest is and how much people want to interact with it. At some point, I would love to have, Voyager Station on there as well, and you can travel between the stations. And there's a million ideas where we could take it. It's just early days. But it's exciting because Dream Big World approached us with this idea, and they're eventually going to be on Pioneer Station physically, and having the digital piece in the near term is fun.
But I can ask one question, since I was talking about launching of the space station modules. Will Orbital Assembly Corporation depend on heavy lift capability of Starship, or can you use smaller launch vehicles like Vulcan, Neutron, or even Falcon 9?
Yes and yes. So Pioneer Station is designed to be fully assembled using existing launch vehicles. And we're really excited for Starship. Once that comes online, that's going to revolutionize everything. But we're trying to run a business today, so we can't bank on what another company may or may not do. And while we have full confidence that Elon Musk is going to get it to work, that's a big unknown. And so right now, everything that we're doing can be done with existing launch vehicles. And once Starship's online, then we'll be able to pivot and do bigger and better things. But we're not banking the future of the company on that. And we talked about this briefly in the break. One of the things that still is a real barrier to entry, we've seen the cost of payload to orbit drop significantly, right? So, looking at the peak of the shuttle program, where by some calculations it was $60,000 per kilogram, down to kind of the last 60-year average of $8,000 a kilogram. We're now seeing prices with, for example, the Falcon Heavy, which just launched this last month. I think price per kilogram is somewhere around $2,500 a kilogram. And I think Falcon 9 is around $3,200, $3,200 a kilogram. The prices to get payload to orbit have dropped significantly. But to get people to orbit is still prohibitively expensive. So some reports are that, with a Dragon capsule, it's about $55 to $60 million a seat to get somebody to orbit, right? If you're going suborbital with Blue Origin or Virgin Galactic, you can do that for thousands of dollars. But to get to orbit is still in the tens of millions of dollars. And I think Starship, the big shift there, we're going to be able to get people to orbit a lot cheaper, right? I think Elon's talking about 100 people to Mars. So, how many people can you take to low Earth orbit? I would imagine quite a few more. But even 100, we're now talking much lower price per seat to get somebody to space. And that is the big shift that we need to still see happen if we're going to have large communities on orbit. I think there's two scenarios. One would be Starship comes online, price per seat drops significantly. Conversely, we could see a large number of commercial platforms on orbit that are highly profitable, and those companies are willing to pay the bill to get their customers to space. And so you start to see a lot of employees or workers, a workforce on orbit. But in that scenario, tourism would still be limited to the super wealthy, right? And so one of the things that Orbital Assembly really wants to see is large numbers of people just visiting space, whether it's for a couple weeks, a couple days, a couple months. Eventually, we'll have large numbers working in space one way or the other, but getting access for the average person is something that's important to us. We believe that by having a destination where those people can go, that will in turn spur the economy. But it's this whole chicken and egg thing we've talked about previously. So Starship accelerates that process, but even without Starship, it's going to happen someday. That was a long answer to a question that I don't remember what it was.
Yeah, good answer. Right, we have a couple of interesting questions from one of our viewers who is working on, nuclear plant and has some knowledge about radiation. So we'd be quite interested to know, how do you plan on protecting the station from radiation? Will there be some combination of Kevlar, water?
Radiation is an issue. The two biggest health effects or impacts for people on orbit are microgravity and the radiation environment. So we're finding solutions for the microgravity problem through our rotating space stations. But the radiation issue is the other side of that health coin that needs to be addressed. So we do have a company that we're working with that has developed a lead alternative material. So it's a polymer-based material that behaves like lead, and it can actually be fabricated in a number of different formats. It can be injected into cavities of structural materials. It can be applied as a film. It can be adhered with a sticky backing. And they have some of their material right now on the International Space Station. They're supposed to get the testing data back on that in January. But right now it's looking very promising as far as the ability of that material to absorb certain spectrum of radiation. Now, you still have, the occasional solar events, which send out a number of, energetic protons, other materials that are very damaging. And so in the station, we're designing areas of refuge. They're shielded with a combination of high Z, low Z material, water being one of them. This material that I mentioned is the other one, plus a couple of other things. And so in those solar event scenarios, the people on the station could go to these safe areas and be protected. And then just for the normal day-to-day operations, we would have a level of shielding that would be reasonable to protect from most radiation events. So that's our current plan. There are some other kind of cutting-edge, innovative technologies that companies have we've been in discussion with, but they're not quite ready for use on orbit. So in 10 years, my answer might be completely different, but that's our plan right now.
What kind of data connection will we be using? Could a call center type business run from there with near instant voice calls, for example?
So there's a number of different data connections we're looking at. There's several different providers. The real challenge with VoIP calls isn't so much the bandwidth, but the latency. And so you really can't overcome the latency issue, at least not with our current understanding of physics. So VoIP calls are going to be challenging. In fact, we were talking previously about the Dream Big World metaverse experience, and we were talking about, are there ways we could have an experience where somebody could make a VoIP call or have some data exchange and experience the latency just to, I guess, annoy you. But it's a real thing. As we start moving out to Mars and even the moon, latency becomes a really significant issue. But we're looking at a number of different data use cases for Pioneer Station and the platform because of latency and data throughput issues. There's a tremendous amount of data that's collected through sensors and other satellites on orbit. And then typically that data gets sent down to the Earth for processing and then back up to the satellite constellation for distribution or command control, that sort of thing. And so we're looking at actually putting data centers on orbit with Pioneer Station. So where we can have all of the data collection and sensor arrays sending that information to a server farm on Pioneer that then does all the AI processing or whatever additional data collection and filtering. And then you're just sending down the information you need, not the whole data set. So there's a lot of interesting possibilities there. VoIP calls, we'll have to see what we can do there.
I've always remembered that Mars, you're 11 minutes away from data retrieval. So that is challenges to overcome.
Right. There's some things where, like data, transmission to Mars, for example, you just build into your operation procedures that real-time data transfer is not a possibility. LEO is a little closer to where for most data operations, it's not an issue at all. And really data transmission, there's enough ground stations that you get quite a bit of coverage to be able to transmit data. There's still a couple of blind spots on the Earth. And with Pioneer Station, where we're planning a sun-synchronous orbit, we're actually going over the poles and we're going to be traversing the entirety of the Earth's surface, right? You're going to see everything. ISS right now is operating in kind of a mid-inclination, so they never get to higher or low latitudes or longitudes. So there's going to be some dead spots that we'll experience that ISS doesn't, and we're working with some partners to try to close those gaps as well. But the latency issue, you really wouldn't notice it except for probably like a live VoIP call. Or if you're trying to play video games, like, I keep losing, what's going on?
A huge orbital station requires significant power. Is the solar panels on the back of an orbital station? How are the orbital nights catered for? Is it batteries, or is that an OAC project going to go minimally nuclear?
Not nuclear at this point, but you touched on really the big thing there, which is the night periods. So there's a number of orbits that we can select where you minimize the periods of eclipse. So Pioneer Station, we've designed that actually to work in sun-synchronous orbit, which means we go over the poles, and we can follow the terminator line. So the terminator line is the point between light and dark on the planet's surface. It's our sunset, sunrise. So we can just follow that around. And actually, because the Earth isn't quite a sphere, it's an oblate spheroid, you get a bit of natural precession. So the orbiting station, as it orbits the Earth, it naturally moves and follows that terminator line. We'll have to do, some orbital maintenance and corrections from time to time, but it's pretty close. So what that means is that the one side of the station can always be facing the sun. Now, there still are periods of eclipse, but they're short. They're measured in minutes, and they tend to be caused by the moon, and they're not detrimental. We would have battery backup for those scenarios, but again, those are fairly small. And then the batteries obviously would be there for emergency procedures and failover as well. But what that allows us to do is all of our solar panels are actually fixed to the station. If you look at ISS, all the solar panels are constantly moving to track the sun, as are the radiators, because the radiators need to be in shade. And so with Pioneer, we can have all the solar panels on one side, all the radiators on the other side. The solar panels are always in sun, and the radiators are always in shade. Now, the one challenge with the radiators, we don't get perfect shadow with the radiators because the Earth actually reflects back quite a bit of energy. So you lose a little bit of efficiency from the radiator faces that are facing towards the Earth. But we should have plenty of solar power. I don't have the numbers off the top of my head right now for exactly what Pioneer is going to have. For Voyager Station, we're talking megawatts of power because it's so big. And Pioneer is in the tens of kilowatts of power.
Tim, you spoke earlier about you might have to do some orbital maintenance and corrections for the keeping in procession with the Terminator line there. How are you planning on doing this? Are you going to have your own thrusters on the station, or will you be using, I believe one of your vendors had the Dream Chaser, would any attached Dream Chasers be responsible for using some of their thrust to help you? What does that look like?
Yeah, that's a good question. So the attached spacecraft, they're there mostly for emergency return capabilities and for delivering crew to the station. We've seen with ISS that relying on visiting craft for boosts, it works fairly well, but you have kind of this weak link of what craft are available. And since Orbital Assembly is not producing spacecraft, we don't want to be reliant on an outside third-party spacecraft to maintain our orbit. You just never know. We don't want the space station coming down because we, had some issue with our launch provider. So all of the orbital maintenance is actually being done with the propellant on station with our own engines. And so the station actually is going to have both Voyager and Pioneer designed with rocket engines, right, that will allow for spin up and spin down. And that's the bulk of our propellant is the spin up and spin down maneuvers. Precession and orbit maintenance are fairly small in comparison for the amount of orbit or for the amount of propellant needed. And the stations actually, so if you recall, one side of the station is facing the sun, one side is facing the shade, and the narrow edge is the side that's the direction of travel. So the station almost rolls kind of around the Earth in a sense. And so because you have that narrow profile, there's a minimal drag profile. Your listeners are pretty educated, but for those who may not know, even up at 600 kilometers and above, there's free atoms floating around, primarily atomic oxygen, and they hit the station as you're traveling, and they actually slow down the station. And that's what causes orbits to degrade, you're getting drag essentially, and it just slows the station down to where you fall into the atmosphere eventually, which is a bad thing, right? But so the narrow profile and the station has a lot of mass, so we have quite a bit of momentum, which decreases the impact those oxygen atoms have on slowing the station down. And then we've got these big beefy engines for spin up and spin down. So we can handle all the orbital maintenance. And one question we often get is, are we using reaction wheels to do control? And the answer to that's no. It would all be chemical propulsion.
Are there any job opportunities that our viewers may want to apply for?
Job opportunities. We are always looking for good people. We're not hiring at the moment, but when we do start hiring again, it's always good to have your information, and then we can go back and contact you. I think the best way would be to email us at info@orbitalassembly.com. You can send us your resume and say, I'm interested in future job opportunities, and then you can go to our website and sign up for newsletters. We would send out a notice for hiring. Typically, our hiring has been more of looking at who's sent us information and who we've had conversations with. I think probably the best way, if you really wanted a job, would be to try to meet one of us, either like this with a video call or in person, and sending us your resume and maybe asking for a call would be a good first step.
All right, that's it for today. Thank you very much, Tim Alatorre. This interview was great, and see you another time.
Thanks so much.